All right, 8th grade, let's go through our textbook. Page 387 through 401. Starting up at the top, we should have highlighted what the wavelength is. When you think of wavelength, you need to think about distance because it says the word length. So wavelength is a distance. Frequency is going to measure the number of waves. So you can take frequency a little bit further because it's the number of waves per second. So I hope you highlighted that. Moving on down, electromagnetic spectrum. You should have highlighted radio waves, microwaves, infrared, visible light, UV, X-rays, and gamma rays. I talked about each one of those. For your answer to number 6, write the parts of the spectrum in order from lowest to highest. So that's going to be the part that gets us is thinking about lowest. So if you can at least get them in order in your mind using your rabbit's mate in a mnemonic device. So if you start with radio, you would just list them this way around. So I'm just going to write the beginning letters. Radio, microwave, infrared, visible, UV, X-ray, and gamma. I ran out of room on my paper. So that would take you from lowest to highest. So that's what you just have to pay attention to. Which way are they asking you to write them? For number 7, electromagnetic radiation. That has a shorter wavelength, has a higher frequency. Remember, wavelength and frequency are inversely proportionate. So if you increase one, you will decrease the other one. So radiation has a shorter wavelength, with a shorter wavelength has a higher frequency. Okay, turn the page. Let's see if we can see that. All right, so looking at a spectroscope, where light's passing through a prism, we can show that it breaks the colors apart on the detector. So for number 8, complete the map by filling in the circles. How is it used to gain information about the universe? So the spectral analysis gives us 3 things. It can tell us the motion of something in space, like a star. We saw that if we're talking about, let's explain that, come over here and add that can be red shifting or blue shifting on the spectrum, if it's moving away or towards us. So we remembered red shifting is moving away, that moves to the red end of the spectrum, versus blue, which is coming to or toward us, like Andromeda. Okay, looking at the next one could be distance, and then different properties. So we talked about the properties that a star or universe could have based on the color of the element that it's going to show us. So motion, distance, and properties. All right, moving to the top over here. We should have underlined or highlighted a continuous spectrum is made up of all the wavelengths of visible light. There should not be any gaps or any breaks in a continuous spectrum. The word kind of makes sense. When you hear continuous, you know it's going to be going on and on and on. Something that's continuous never stops, kind of like Miss Kirby's videos. All right, and then when you have an emission spectrum, that's going to be unevenly spaced lines of different colors, because that is only what is being emitted, or another word you could say would be released or put out. So whatever is emitting, if something has an emission spectrum, that means it's absorbing almost all of the colors, and it's only letting those colors show. Then an absorption spectrum will be the opposite. It looks similar to your continuous spectrum, but it will have dark lines, and those dark lines, we know, show us which gas is being absorbed. All right, so let's look at number 10. How are an absorption and emission spectrum used to determine the elements that make up a star? So each element has a unique spectrum, and that these are like fingerprints. They're going to be different for each element that we come across. So that's your number 10. Okay. Let's see. So now we're talking about Doppler effect. Don't worry if this is confusing. We're going to have a whole gizmo on this, so I'm sure that will be fun for you. So I'm just going to show you because I do not want to write this whole answer. And it's early in the morning and my class is in here, so there you go. Copy that answer down. Teacher of the Year. All right, so the way a Doppler effect works is that wavelengths are compressed. So if you think about the word compressed, they're going to be closer together. They're pressed closer together as the vehicle approaches the observer, which will give you a higher pitch sound. So when we get to sound waves, some of that's going to make more sense about how when they're closer together, that's going to change the pitch of a sound. When the vehicle passes the observer, the wavelengths stretch out and the observer hears a lower pitch sound. So pause it if you need to see that, and we're going to move on. On 393, go back out. Other direction, I'm so sorry. All right, on 393, right here where we're visualizing, here's our emission spectrum. We're talking about the element hydrogen. And they're going to give us a red shifting and a blue shifting. So let's look at the question. The hydrogen spectrum of, oh cool, Andromeda. Obviously I looked at this ahead of time. It's similar to the bottom spectrum. So how is this galaxy moving relative to Earth? So if this bottom one represents Andromeda, our closest galaxy, let's look at these spectral lines. So if you took a ruler or something and you tried to move them up or line them up, if there's a line right there on this top one, then where is that line? I have to move to the right before I see it, which is moving to which color end of the spectrum will be the blue end. So let's try that again for this one since that's easy to see. So if I line up my ruler and I see this red line up here on the top, I had to move to the right before I could see that line. So that means this line shifted this direction. And this line shifted this direction. So they're moving to the blue side of the spectrum. So that means it is moving toward us. Okay. All right, looking at some telescopes. So I'm going to trust that you guys read these, and I'll zoom in on my answers down here. There we go. Alright, so if you want to, go ahead and pause your video so you can read those answers. Alright, I'm going to go ahead and move to the next page. And here's your 487 answers. 396 and 397 answers. Okay, so pause if you need to. I'm going to flip the page. Oh my goodness. All right, here's your answer for 19. The question was compare one thing about Andromeda on the opposite page with the image in visible light on this page. So when we look at it, it's going to look completely different than when we compare it when the image is taken with different types of telescopes. So pause if you need to for number 19. And just to save me some time, because we're about to have class, there's your answers to your review. All right, so pause if you need to. I'm going to turn off the video.